Okay, so the leading coefficient, now it's not necessarily just the number that's in front. What do you think has to happen first before we determine what's the leading coefficient? Put it in standard form. So let's say I had a polynomial that looked like this, like 2x plus 4x to the fifth plus 3x minus 1. What's the leading coefficient?
4.
The coefficient is a number that's multiplied in front of a variable, so the leading coefficient would actually be 4. You have to put it in standard form first. So, and then the degree we've talked about before, the degree is the largest power. When it's in standard form, it's going to be the first term. So if this wasn't in standard form quite yet, what would the degree be? 2?
5.
The largest exponent is a 5. So I would say that has a degree of 5. Okay? We've named these before, right?
5 degrees.
How many terms does this have?
4.
How many terms does this have?
4.
4. The constant term of this one is what?
1.
What's the constant term of this one? Negative 1. It's the last term. It's the one that doesn't have a variable. The constant. It's constant. It's not multiplied by any variables. Okay.
Wait a minute.
And that's pretty much it here, right?
Have
This is called the end behavior of a polynomial. And there's 4 scenarios. So go ahead and add the arrows into your graphs real quick. Just add the red arrows.
Do you have a red pen?
The end behavior is of a polynomial is basically where it's coming from and where it's going. It's the loose ends of the rope. So we can start at the bottom and we can end at the top. That is one scenario. We can start at the top and end at the bottom. We can start at the top and end at the top, and we can start at the bottom and end at the bottom. Now, do we know what happens in between? So that's why it's called the end behavior. We don't know the behavior of the middle. So maybe it's just a line, right? Linear, just looks like that. It starts at the bottom and ends at the top. Maybe it does a little loop-de-doo or two and has a few x-intercepts. Okay? Maybe it does a whole bunch of stuff. We've seen some of them that get really crazy, those higher degree polynomials. We don't know what happens in the middle yet, but we can determine the end behavior here in just a minute. So, and then the way we're going to write these, it's kind of fancy. Down at the bottom, underneath that, this is how you're going to write the end behavior. So what it means, as x approaches positive infinity. Ryan, what direction is that? Well, in what direction is that? As x approaches positive infinity. Right, left, up, down.
Right.
It's to the right. So this is saying, as the graph goes to the right, what's another way to think of f of x?
What?
Y. F of x is called the outputs. It's f, the function of x. So y is going, and that's what you have to fill in. So it's asking you, as x is going to the right, so as this graph goes further to the right, what's happening to the y values here? They're going to positive infinity. Plus infinity.
Nice.
Polynomials always go to infinity somehow. They go on forever in one direction. Now the other part, as x goes to negative infinity. What direction is that? Left, right, up, down? Left. As x goes to negative infinity, f of x, also known as y, is doing what? It's going to negative infinity. So you're just filling in a positive infinity or a negative infinity.
That's it. No.
Yep. Try and finish those off. Do the last 6 of them there. So the last one, regardless of where x is going, where are my y values going?
Down.
Negative infinity to negative infinity.
No.
And that the only thing that matters is the leading term. There's some other stuff that happens here. None of it matters. The only thing that matters is the stuff in front. And the only thing that matters from that is if A is positive or negative, and if N is what?
Odd or even.
Odd or even. Those are literally the only things that matter. Okay, so let's do our scenarios again one more time. If N is even, it's one of two. What is it? Up, or down. But if it's positive, it has to be up, which means this one is down. What are some even functions? What's the most obvious one that we've been doing all year long?
2.
Quadratic, x squared. But that applies for everything else, like x to the 4th, and x to the 6th, and x to the 100th. All of them have the same end behavior.
What about 3?
Not 75th. Okay? If n is odd, we have two scenarios. We're either going up the mountain or down the mountain. So if it's positive, we're going up the mountain, which means we start at the bottom. If it's negative, we start at the top of the mountain and go down. So now, real quick, wait. I want an example in each of these boxes of a leading term. So remember, none of the other stuff matters. I'll do the first one. An even positive would be something like 2x to the 6th. 2x to the 6th would have that end behavior. Austin, what's an example that would have this end behavior?
So you'd have, like, you could put negative and then like 2.
Negative 2, okay, that's the leading coefficient. X to the
And then since it's even, it'd be like 2.
any number, 2. Okay, that works. Any even number.
Not 1.
Trevor, what's an example that could go in this box? It has an odd degree, but it has a positive leading coefficient. Anything in the world. 2x to the 5th, perfect. Now don't confuse 2 with an even number, right? I don't care if that's even or odd, I only care if that's what? Positive or negative. The 5 is what I care about being odd. And then the last one, Jace?
Negative 6x to the 75th.
Good. That's for Avery.
Yeah, it was.
Oh,
you're so sweet.
What is the leading coefficient of number 1?
2.
It is 2. But most importantly,
oh my.
it's positive.
No.
Based on some of your snapshot grades today, I would be paying better attention.
Damn.
Tyler. What is the degree of number 1?
3.
3, but really, what I care about that is what?
It's odd.
It's odd. So I'm kind of putting in parentheses the things that we really care about. I don't care that it's a 2, I care that it's positive. I don't care that it's a 3, I care that it's odd. So now we know that it does what? A positive odd function. Anytime you hear the word odd, I want you to think of a straight line. Straight lines either do what?
Go this way or
This or that, that's it. Well, in behavior, it can be flat or vertical, but if we're talking about switching, okay? So a positive odd is like a positive line. Show me with your arm, what does a positive line do? No.
No, that's it.
Up the mountain. Up the mountain. Write that down. Now we have to write it our fancy way. End behavior. This is how we write our end behavior. As x goes to the right, I'll say positive infinity. You don't technically have to write a positive.
Yeah.
F of x approaches what? As x goes to the right, as we go further right on our graph, what's happening to my output values?
Can you put y?
To positive, no, do f of x because it's a function of x. And then the other, that's only half of it. That's telling me what's happening to the right. Now we have to go to the left. So as x goes to the left, also known as negative infinity, where are my y values going? To negative infinity, down.
Whoa, what?
As x goes to the right, the graph is going up. As x goes to the left, the graph is going down.
So you write 2.
I would say that the leading coefficient is actually negative 2. If I were to write this in standard form, it would be negative 2x to the 4th plus 3x minus 5. So, most importantly, it is negative. And the degree is 4, but most importantly, it's even. Anytime you hear the word even, I want you to think of a quadratic. What are you going to think of for odd?
Line.
A line. Quadratic is even. It's either up, up, or down, down. This one is negative, so it is down, down. Which means, regardless of the way x is going, so as x goes to the right, f of x is going to negative infinity, and as x goes to the left, f of x goes also to negative infinity. They're both going down. All right, check your answers for the answers for number 3. Check your answers. I always start out with f of x because it's a function. F of x equals, how many x-intercepts are there on number 1? 3. So I put 3 factors. Now if the 0 is -4, what was in the factor?
X plus 4.
If the 0 is -2,
X plus.
and if this was 1,
X minus 1.
it's x minus 1.
So many people.
Okay.
Did any of them bounce? No. And one more thing. There's more to think of now. This isn't just what we did last class.
Right.
Now we have to do the end behavior. It starts at the bottom, and it ends at the top. So should it be positive or negative? Positive. So leave it alone. What did we do in Desmos when we needed to flip the whole graph? That's where you need to put a negative in front. You have to do that sometimes, so you need to pay close attention to that.
No.
What is the degree of number 4? Remember, in order to see the degree, it has to be in standard form. It would be 3. Can everyone see why it's 3?
Yeah.
If it were FOILed out, in other words, if I multiply these, I get an x squared and then blah, 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 right? Combine like terms, blah, 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 blah. And then what would I have to multiply that by? X minus 1, right? And then I distribute that. So once it's finally in standard form, plus and minus and stuff, what's the degree?
3.
3. And all of the x's were positive, right? So the leading coefficient would be a positive 1. So you have to be careful if it's in, you have to check and see if it's in standard form or if it's in factored form. Okay. Next, let's graph our x-intercepts. So what is this x-intercept? -3. Put it on your graph. -2. Put it on your graph. 1. Put it on your graph. Here's 1. -2. +3. Sorry, -3. Those are close together. We now notice, or earlier, we noticed that it's a positive odd degree. So it's like a line. It's positive. Where's it going to start? At the bottom. So just put an arrow down here, and then it's going to end up at the top. Does it bounce on any of them?
No.
No, this is called the multiplicity. Have we seen that word yet?
No.
I've seen both sides.
We'll do it on the next page. So all of them are going to cross, right? One more thing I want you to find. I want you to find the y-intercept. Okay, how do we find the y-intercept of any graph ever?
X equals 0.
You plug in 0 for all the x's. So go to your good main screen. It's 0 plus 3, 0 plus 2, 0 minus 1. So just graph or write the equation, plug in 0 for all the x's and hit enter. What's my y-intercept? -6. Go ahead and write it as a point. So over 0, down 6. Go ahead and put that on your graph. That's just another thing that makes it more accurate. Now's the fun part. We know all the pieces. Now we're just going to go on a little roller coaster ride. So we're going to start at the bottom of the mamba. We're going to cross. We're going to cross. We're going to go down and hit the y-intercept. We're going to cross, and then we're going to end up.
Wow. Does it matter how far?
Not right now. Later on, I'll show you how to find out how far up or down you can go. But for now, it's just kind of like a sketch.